哦，所以原本你要做这个，就开始。所以呢，一个是你的没有加成，这些主要是 X 系列。完了，那你现在还是
Okay. So, first of all, welcome to you and thank you for taking this 7-4 machine learning meeting. I'm the constructor of this course, and our TA is Lincoln. Lincoln here and Riley. Okay, so there are TA that will help you to arrange the project and also mark the assignment. And so the purpose of this course basically is to introduce you various machine learning techniques and then show you some examples on how to apply this technique to various important problems in finance and trading. And now please understand that we have only 10 weeks, so it is not possible for us to dig deep to every topic. So I think it's kind of acceptable that we will just give you some very illustrative example on using the machine learning technique to solve first problem. And so basically, we will make sure that the class, sorry. Wait. Hi. Hi. Hi.
好啊，好啊。不該咁咧，我而家上緊堂，咁你禮拜一同禮拜四，係禮拜晏晝同禮拜四晏晝，係啊。都唔知啊，不過啲學生等緊我，裏面有成100幾人喺度望緊我。係，拜拜。Okay.
So in order to So we will show you the topics to be covered in this course in the next slide. But before doing that, maybe we give you some more detail about this course. I've already introduced the instructor as well as the GA for you. Now for the assessment, basically this course has only one programming assignment. And in the assignment, we have 2 programming questions. Each question will cover different topics related to applying machine learning in finance. Okay, but it will only account for a weight of 25% of the total weight of this course. And another component is very important to this course is group project. And this group project accounts for 40%. Now, as I mentioned earlier, the design of this course will first make sure that it will cover enough different topics, go through different kind of machine learning techniques. So you have a good idea on the whole kind of the more or less the larger picture on this field. Okay, so the part we have to make sure that it is broad enough for different areas. And however, we also want to make sure that the student will experience some make sure that the depth of this course will also be covered in this course. So in group project, the purpose is make sure that you can dig deeper into this field or this area. Okay. So now, basically, we are in an MSc course. So this we will expect the student will have the capability on self-learning. So in this project, we will expect our students to pick up one interesting topic, okay, of their own, and then they will spend time and effort to assess the necessary material about the topic that is interesting, and then either they decide whether they want to develop a system, okay, to implement something for the topic, or they can do some data analysis and use machine learning to build some model and do some prediction, or read some paper that is kind of the frontier of the research, and then they will tell us, okay, what is happening, okay, in the future. So basically, this project group is also very important a component. So, the arrangement of this project group, we expect the students are contribute with about 4 or 5. Now, since now the class size here is quite large, so basically I would expect that every group will be around 5 students, and then each group will choose a topic related to machine learning and finance and trading, okay, and then work about 7 or 8 weeks, and they will try to, after that, they will make a presentation, each group, and then each group will prepare one single group report. So the purpose of this group project not only push you to self-learn some topic, okay, but also give you an opportunity so that you can work with other students. Okay, so you will learn how to communicate with others, try to motivate others to work on the project, and if things doesn't work well, how to say, make sure that you can overcome the kind of the different opinions or different working skills. So it's also a very good experience for you to develop, okay, some skill for group collaboration. So this is a good project. I'll give you more detail about the arrangement in a minute. And finally, we have a very simple final exam. Okay, so this is kind of the assessment of this course. Now, you see that we have 10 weeks. So we will use the first 8 weeks or first 8 lectures to cover the various topics on about machine learning and finance. And then the last 2 lectures will be used for project presentation. Okay. Now, in the first 8 lectures, so we use the first 2 lectures to cover the essential stuff that you must know in order to start the discussion of applying machine learning. Okay. Of course, if you do not know nothing about machine learning, then it is kind of not really reasonable to jump into applying machine learning directly to various big problems. Okay, so now I understand that some of you undergrad in the undergraduate study, they have already taken some machine learning course, or they have already taken some data science course, that they have already have some experience on using say NumPy and Pandas. Okay, but I just want you to understand that this class size is around 150, and we have many students from different backgrounds. As a matter of fact, we have some a significant number of students at Icon Econ, and their major is not from BCS. Some of them are from business. So they may not be that prepared, okay, to start the discussion on machine learning, applying machine learning in the problem. Okay, so I would ask for your patience so that in the first lecture I have to quickly cover all the necessary background, so that after that then all students will be at the same level ground, so that we can start the discussion. Okay, so I'm sure that in our discussion there are many stuff that may be new to you. Okay, so maybe it's still worth your time to go through it. So after the first 2 weeks, then we will use cover 5 different machine finance and trading different area or problem, and then see how to apply to different machine learning technique in order to solve that. And first, we will study how to apply machine learning to detect financial fraud. And for this part, basically the most important step is to clear the data before you do the machine learning model building. So in this part, we will learn a lot of techniques to say clear the input data, to prepare it so that it will kind of ready for the machine learning part. Yeah, so it will involve various data science techniques applied the function provided by NumPy and Pandas, so you can use them to work on the data, make it suitable for the drug analysis. So this is the first part. And then we will also show how to use machine learning technique to predict, okay, finance focus. Okay, so basically we will apply work with such as STM, recurrent neural network, or even simpler, say linear regression method in order to predict a stock price. So for this, you need to kind of know the simple step to assess a stock price from the internet automatically, and then based on the data that you get, then you apply some, say, machine learning building model to do the training, and then the model, and then do the evaluation to see whether the prediction are really, say, in line with real, say, trend of stock price. So the next topic was financial forecasting. Okay, and the third is about the sentiments analysis. So basically, it's involved the natural language processing, so that we can apply some tools that assess the kind of, say, for example, the tweets from the tweeters, or to assess, let's say, for example, I want to say see how the customer feel about a product, say for Nike, for example. Okay, then I will show you how to assess automatically those related with from the Twitter related to Nike, collect them, and then apply natural processing, say, tools in order to understand the, say, the meaning of the tweet, in order to figure out whether the tweet corresponding to the negative sentiments on Nike and negative sentiment Nike. Based on this, it will create a kind of a report on how the public sentiments of the product vary over time. And then you can compare it with the real stock price, say, trend during the period, and then you see how they are related, so that we can learn some idea to use this sentiments analysis result to improve the prediction of the stock price prediction. So this sentiments analysis kind of focus on natural language processing tools on, okay, various articles or message from the public in order to understand the sentiment, in order to have prediction. Okay, next we will the fourth topic that we want to cover is how to use the reinforcement learning, say, technique in order to build a program, or you can call it a training process, but that's a program, so that it can kind of run, okay, for example, they want to go through the different stock price the period of different stock price trend in order to learn how to, say, make the decision on whether we want to buy or sell on every particular day trading period. Okay, so basically it's really learn, okay, the technique of reinforcement learning. Okay, finally we will try to use deep learning to work on option price. So this is the 5 different topics. So we have already, okay, covered a lot already. So basically, we will usually I will just make sure that I can cover one topic in one lecture. That this is what. 2022. And after that, then the last two lectures will be for project presentation. Any questions? Okay. Now, this is the tentative schedule of this course. I don't need to cover it. You can go through it yourself. Okay. But the most important thing is this WeChat group QR code. So basically, you folks do not know each other. Okay? Maybe this is the first class of the course. So you may use this, say, WeChat group so that you can tell every others what kind of topic or at least what area that you want to work on, so that the group you can find some fellow student, okay, kind of persuade him or her to go into group. Okay, so this is kind of a very useful, at least in the last few class, last few semester, this is very useful. Okay, so try to make good use of it so that you can find the group member very easily. Okay, now about the schedule, and maybe I remind you that now today is September 7th. Yeah. Now it will take about 1 or 2 weeks. Okay, so the 21st on September is the last day for you to form your project group. So try to work hard to form a group of 5 students as soon as possible, so that you can discuss the topic that we work on, and then you can start the topic. Okay, and on September 28th, all you need is to submit a title of the project, and then out of the 5 students, you select a group leader. Okay, the major purpose of the group leader is just as a negative contact for us to say find the student in the group to say, for example, make sure their progress are kind of up to the schedule and time. Okay, so this is for communication. So this is very important. Make sure that you can work hard so that before September 28th, then you can submit the title of the project and the name of the group leader. Okay, now, but of course, the project title, okay, is just for tentative. You can always change it at end. As a matter of fact, in the last few semesters, okay, many groups changed the title during the course. Okay, so basically, we understand that it's unreasonable that the first 2 weeks then you find something that you really understand and into. Okay, so basically during the running of the course, then you can always change your title. Okay, of course, when you change it, you need to tell our TA to make the update. Okay, so this is what we have, and also the presentation will be the last 2 weeks of this course. Okay, but then you need to, after the presentation, you need to submit a project report. Okay, and this is the due date for the project report, end of November. Okay, any questions? Yes. Now, then let me explain first what we need in this course. So basically, in this course, we need to handle a large amount of data. As a matter of fact, the magnitude of data usually is a table of about thousands of rows involving, say, different, at least a dozen of columns. So this is a large table of data. And based on it, we need to kind of prepare in such a way that we can First, for example, for fraud detection, we will extract important information on what kind of value that we can extract from this, say, data set in order for us to effectively train a machine learning model for fraud detection. Okay, so in other words, we need to handle a large amount of data, thousands of rows. So just imagine that not even understand the data, but just scroll down on using your mouse in order to get that thousands of lines. Okay, it's already a very time-consuming and tedious task. Let alone that we need to extract different information from this sea of data. Okay, so basically, in this field, one of the very important capability is know how to write program to automatically assess or dig out important information from a large set of data. Okay, so in other words, we need to know data science technique. Okay, so in order to do that, you need to learn the tools to say assess data, manipulate the data so that you can build a machine learning model. Okay, so basically, we need to know something about data science. On the other hand, after getting all the basic skill in data science for our purpose, and then we need to learn some basic about machine learning. Okay, so the example that we give on machine learning is a little bit advanced. Okay, and it will kind of skip many of the basic steps and basic reasons on how to get things done and why we need to do it in that way. Okay, so before we really apply the technique and to understand the underlying rationale on how to do things in that way, so we need to spend some time to get the very basic on machine learning and what kind of issue that this machine learning need to consider. Okay, one of them is overfitting. Make sure that the data you get is large enough, and then you get the information kind of objective enough in order to make your model is can be applied in general, not just overfit training data you have. So all kinds of background we need to cover, and we will do it in the first two lectures. Okay, so without any ado, maybe we start with the data science part. Okay, now as I mentioned, it is impossible for a human being to say handle the data manually. So we need say automatic tools, computational tools for us. Now, basically in the data science field, there's two camps. Okay, that one group will use say based on Python, the programming language. Okay, this group more or less is from the computer science field. Okay, those they love to write programs. Okay, so they use Python and also apply some of the package that are available in the internet in order to use them and write program to do the necessary step in the training. So this is one camp. Okay, and I'm supposed at least this I need to make sure that so for this course we cannot get even deeper to teach Python. Okay, and this course basically is another course. So we will assume that our students know at least some Python. So if you are not that familiar with Python, then I would strongly suggest you in the first 2 weeks to learn, get a simple textbook on Python and learn to fix it as soon as possible. So when in our discussion, I will not explain the basic statement of Python. Okay, so we will assume that every one of us will understand at least the meaning of the basic statement of Python. Okay, and this is Python, and another camp is using a programming language called okay. Now, basically, these two I also teach data science. Okay, and you have already used in some semester I taught the data science course based on Python, and that I will also use in some other semester I use the programming R to teach the data science course. And my feeling is this part totally based on different philosophy, and as a matter of fact, for some application, for some different kind of employer in the organization, maybe for them it is better to use Python. Okay, while for other data scientists, it's better for them to use language R. Okay, because language R is not about writing programs. Okay, it's just like a kind of a command interface. You sit in front of terminal, type every command, and that you kind of like you can massage the data, in your keyboard, and then get the data and see what will be the result in it. Okay, but for Python, basically you write the complete program first. Okay, before you can run the program and see what is the result. Okay, that's but I cannot say that which one will be better. Okay, so both have the suitable application. Okay, but for us, we will focus on Python. Okay, because there's a lot of package that we can make use of, so that we can write program very easily to handle different kinds of problems. Okay, now, and this gives you basically the reason is first, we are computer science students mostly, so we know how to do the programming, especially we expected to use Python. Okay, and also as a matter of fact, both can also have a large number of powerful packages that the user can use in order to apply it to the program to do the analysis. Okay, so now we understand here now the course will use Python, but not only Python, but also use the package that are implemented in Python that is focused on data analytics and data science. Okay, so that we can use them to extract important information. Okay. Okay, so this is an explanation or introduction of Python, but this is not very relevant here because now every version of Python is the Python 3. So a few years ago, there's two groups of Python, Python 2 and Python 3. Python 2 is earlier, but then after a few whiles, the original designer of Python decided to implement another version, but it turned out that the version is so different from, say, the earlier version, so eventually people call not Python, they call it Python 3. Okay, so basically this is two different programming languages, but nowadays most of it is Python 3. Okay, so I suppose you can now, just in case you have another Python, okay, then this slide will give you how to install the Python. And not only the Python programming language, when you do the installation, you will also get so-called the epithet, or the more correctly expressed is so-called the whole interactive programming environment. Okay, and then in this interactive programming environment, then when you install it from the official side, you will also get another program called IDLE, so that you can write programs in it. Okay. Now, but then this is only for those students who have never used Python. Okay. But for those students who use Python, that it is also something new here. Is in Python, usually you use idle, okay, to write the program. Okay. But for data science and for our purpose, we will move something a little bit advanced. Instead of using the standard, say, programming development environment, you just try the idle. Basically, we will use another more advanced and friendly platform is called Jupyter Notebook. Okay. So this Jupyter Notebook is quite different from the standard Python program. So if you still remember, the Python program, okay, platform basically allow you to run a Python program in two different modes. The first mode is called the script mode. For the script mode, you allowed to sit in front of an editor, type the complete program, and then once you finish it, then you can run the program and get the result. Okay, so you need to complete all the program statement, input it before you can run it. Okay, so this is for the script mode. Another mode is kind of an interactive mode. It will behave as if it is a calculator. So you sit and then you type command, type the return, and then you can immediately get the effect of this statement. Okay, so basically, then you will say line by statement to type in the program. Okay. So this is interactive mode. So of course, the script mode is not ideal in the sense that if your program is say have say 500 statement here, so you have typed in 500 statements. Okay, before you can say actually see whether that some say bugs in any part of your program. On the other hand, in the interactive mode, basically it's totally useless. Okay, it's kind of very annoying that whenever you type something, then you stop and then the computer will show you the intermediate result. Okay, so this is too extreme. But of course, what is the ideal case is that allow us to handle this programming, okay, and something in between. What do I mean? The best scenario will be the user decide when to run the program. Okay, that. So basically, it is good that you can type the first 100 lines. Okay, so suppose that eventually you need to type in 500 lines. So after you type in 100 lines, then you can just click the button to run this 100 lines. Okay, and then see how this 100 line behave. So if you get error in this 100 line, you need to proceed and fix this error. Okay, so this will be allow you to get into the different types of your program, see how they behave, correct error much earlier than the original, say, script mode when you run all the program. Okay, so basically, you can imagine that you can sit in front of your terminal, type in some line, run it, or get everything okay. And then you start on continue to type on some line, run it, see what kind of this new line will affect the output of the program, and see, oh, okay, there may be something you don't like it, then you may change part of this, okay, this new line, and then run it without rerunning, okay, the earlier part. So this makes kind of intermediate between the script mode and then the interactive mode to help you to run the program. So indeed, we have such a platform for us to do programming in this way, and that platform is called Jupyter Notebook. So in this course, you will see plenty of samples to use Jupyter Notebook, okay, to develop program, and you will say kind of personally taste, okay, why this Jupyter Notebook are so popular in developing program and data science and learning. Okay, so this is Jupyter Notebook. Okay, this Jupyter Notebook, okay, is this slide is nothing but to tell you some background on the implementation and the design of this Jupyter Notebook. Okay. And this Jupyter Notebook, even though we use it to write Python programs, as a matter of fact, this platform are general enough that allows us to say develop a program written in another language called Julia, and also develop program on another programming language. Okay, but anyway, we will just use the notebook to write Python programs. Okay. Now, in general, the basic arrangement of a Jupyter Notebook, okay, is not a single sequential list of statements, but instead a collection of boxes. And there's different kinds of boxes called text box, math box, and single box, and so on. But the most important kind of boxes is code boxes. Now, these code boxes essentially is sequential, but when you run it, you can first open an empty code box, and then you type in your program in this code box, and then you can run only the statement in this code box in order to see the result. Okay, so basically, this code box is just contain a sequence of statements that allows you to run, okay, only those statements at a time. So basically, what you need to do later, you will see that, or open a code box, type in some statement, run it, see what the intermediate result is, okay, and then based on the result, I may get some idea on what will be the following statement is. So now I have done another code box in the following, and I type in new statement. Okay, then maybe at some stage, typing this statement that the result may not be what I want, then I can just change the statement in this code box without rerunning the whole program. Okay, so this is kind of nice for us to do the development. Or there are other kind of code boxes. So later you will see some example, but this is the most important, the code box. Okay. Now, this is an example on writing a Python program using a Jupyter Notebook. And the important part is here, basically it shows you, okay, the different boxes, type of boxes. So first is the text box, a text box that you can type an ordinary command or passage, so that it's kind of for being comment. Okay. And here, the next one, this is a code box that contains, say, here is just two statements, so you can actually execute it. Okay, and then followed by another text code box saying that the following is the body of the program. So this is ordinary text. It's not a programming stage. Okay, And then this is another cookbook. Okay, that you can type in different statements of the Python program, and then you run it, then finally you get the output cookbook. Okay, it's not cookbook, it's the character. So basically, this is an example, give you some idea. So what we need is, now, we seldom use this text cookbook, okay? For this, basically, it is for those that use different notebook to write text box, okay? But it is usually we will not use it, so we will use the cookbook to type the program. But instead of type the whole program, we will just divide it in different parts and then run it, okay, box by box, okay, and then get the result. I will give you the example in a minute. We'll get back to this example also later. Okay, but anyway, just give you the idea on what is looking for. And this gives you a better things. That's exactly what I just said, the different kind of boxes. Okay. So this is a summary of what I just said. It allows us to write program in okay. So it will make implement of the situation with more say much more easy to do the design. Okay. So I just want to explain why this kind of arrangement of platform are so popular, because it exactly will fit in the working paradigm of the data science. So data science basically is analyze the data. So usually at the beginning, you do not know what is the correct way to manage and take out the data. So usually we'll say open a cookbook, type in the statements, run the cookbook, see the result, and then see what will you get up to that point, and then you can, based on the intermediate result, decide what is the next step to extract the data, or at some point whether you can throw away some of the data. But at the very beginning, you do not know exactly what you need to do. So basically, this kind of interactive will kind of make you make better decision on various stage of your analysis. Okay, so this is why it is so important. Okay, so this is kind of advantage here. And now, maybe I give you an actual example first, and then we'll get a better idea. Okay. Okay. Now, this platform is called Google Colab, and I will describe it more in a minute. But anyway, in this platform, I just showed you, okay, the what really look like as about what I've just explained on interactive program. So, for example, I want to run a program. Say, for example, n equals to 1, b equals to 3, c equals to 4. Okay, then this is the statement, and then you immediately run it. Okay. Okay, then it already run it, and after that I can
open another cookbook, okay, to say print A plus B plus C, okay, and then run it. Okay, so this you can see that I can just whenever at some point I want to see the result, and then I run it and then get the result. Okay, and then based on it, then I can add another cookbook to continue for an analysis. And as a matter of fact, if you really like it, then instead of cookbook, then you may try to add a text box. Okay, this is only a command. Okay, and then after that, okay. Then you see that there's another box here. Okay, so this is just give you some example here. Hope that is clear enough. Okay, so this is so-called using Jupyter Notebook. Now, so from this eventually, you will eventually have a complete program. Okay, and a lot of statements. So it's collection of code forms in which there's a collection of sequence of statements together form a file, just like what you have done when you write a Python program. Okay, and then all the statements you store in a file, and they are called a Python program. Now, if you still remember, and if you write a Python program, then you need to give an extension of that program. The extension is .py. Just like you write a C++ program, then you have a file name, and then and then a dot. After that, you have CPP or C++. Okay, so the extension is kind of a label to tell the language that this program is implemented. Okay, so for Python, if you still remember the extension is .py. Okay, but if you implement the Python program using this so-called Jupyter Notebook, that eventually the file that you have developed in this Jupyter Notebook is not in Python format. It's a little bit different. Okay, you can say that it is in Jupyter Notebook format. Okay, so basically you need to a little bit aware that for this kind of program developed by Jupyter Notebooks, okay, its extension is JP, okay, JPYNB, Jupyter Notebook, okay, JPYNB, not .py, okay. So this is the one you need to be aware, but it is not that that problematic here because right. Okay, now, so you see that this is Jupyter Notebook, but the platform that I'm introduced to you later in a minute, that you can kind of save it, okay, back to a in the Python program form. Okay, so basically it's not really a problem. Okay, so if you eventually want to have a Python program, then you can convert it back. But when you develop your program using Jupyter Notebook, then the file should be having an extension on the PYNB, for the extension. So this is some explanation of the extension. Maybe we can skip it. Okay, you read yourself. Now, so one advantage I've already introduced to you is you can using Jupyter Notebook to develop your program interactively and by component. Okay, this is one advantage. And the second advantage using Jupyter Notebook is because that the interface, in fact, the Jupyter Notebook can be handled by a web browser. So as a matter of fact, all you need is to the server, you have a Jupyter Notebook installation, and your client, and all you need is to open a web browser, go to that web service, and then you just use this web server to write the notebook. Okay, so you don't need to install anything that into the computer in order to run. Okay, so this basically is another advantage that you will see, namely that you don't need to install your anything in your computer, okay, but you can run your Jupyter Notebook using the web browser. And as a matter of fact, together with this capability, not forget about any content. Okay? Together with this, there's a very convenient platform for us to write Jupyter Notebook. It's called the Google Colab. Okay, so I'm now just illustrate to you how to use Jupyter Colab in order to run a Jupyter Notebook program, so that you don't need to install anything in the computer. All you need is to use Google Drive to access the program, and then it will use the web browser in order to do the program. So this is very convenient. So now I'm going to introduce to you this very convenient platform, so that this course will use this platform in order to write the notebook in our example. Okay, now in order to write program in this platform, the very important thing is you need to have an account in Google. But of course, if you already have a Gmail account, then you have already can use it. Okay, so in other words, when you go to Google, and then if you do not have any account signed already, then it will ask you to type in your account or create a new account. And in order to use it, since I already account, and this is my account name, so I just type in account, and then will bring you to the platform. Okay, if not, then you can just type in this to establish a new account, and then you follow the instruction. All you need is basically to give you a normal email address and together with some personal information, and then you can have an account. So now, once you can log in Google, and of course you will see it brought you to this pages with your account. Okay, logged in. And in the one of the say top bar, there's a say a button here that when you click it, you see a lot of applications that you can use. Okay, for Google. Okay, so for Gmail, for YouTube, okay, search, map, and that kind of thing. But that one particular application, okay, that is important for us is the Google Drive. Okay, Google Drive usually is allow us to store different type of say document or programs on the server of Google. Okay, so when you type in Google Drive, okay, and then it will bring you to the pages for Google Drive. Okay, so maybe a little bit out of the context here. Maybe I run it for you and then you see what's going on. Okay, so maybe what's going on? Okay. So you go to the Google page, and now for me, here I've already logged in my account. But if you say do not have your account logged in, then you can log in your and add a new account yourself, do the thing. So in this page, and there's a button here that lists all the Google apps that you can use. Okay, a lot of say apps. In particular, we are interested in this app called Google Drive. And this Google Drive is just a say kind of a storage for you to store various document or programs or whatever file that you want to store on Google. You type it, basically it will bring you to a page that is kind of like a page that you see when you open a folder, and then you see that there's in this at least for me, okay, in I'm a Google Drive that I have this set of folder, and then I can type it and then enter it to see what happened. Okay, but now for us, basically you need, for example, you need to write a new a Jupyter notebook. All you need is to open a new file. Okay, so here you just type new here. Okay, and for this new button, that it allows you to create various types of documents or even new folder and so on and so forth. So you can create a new Google Doc, new Google Sheet, and so on, and drawing, site, and so on. In particular, I want to bring your attention to this, okay, application called Google Colaboratory. Okay, this usually we will just simply call it a Google Colab. Okay, so this kind of file is called Google Colab file, and you just type it and then you create a new Google Colab file. And when you type it, then you will see that this Google Colab will bring us, okay, a page that allow us to type in Python program using Jupyter Notebook. Okay. So this is the simple way for us to write a new Jupyter Notebook program. Just go to a Google page, Google Drive, and then type the application button, get the new button to get the new file. And the new file type will be for Google Colab. And after that, then you have a file here. Okay, and once you then you maybe you type in plain hello world. And then kind of like this. Okay. Okay. Then you print how 101 is the name and Peter, and then just go. Okay. So this is the program that you have written. This is a Python program. Then after that, you can simply, okay, go out, and then you see that your Google Drive now will have a new program. This is the program that I've just typed. Okay. So of course you can change the name, and then you can have, say, a real application for your program. Okay. So now this file is not in your computer or in your PC. Okay, it's in the Google Drive. Okay, it's the server of Google. Okay, so but for me it's okay, because it just every time I just go to this Google Colab and then just type in, okay, go into this Google Drive and then just open the file that I've developed earlier. Okay, it's very convenient. But however, at some point, and if you really want to, say, move your file back in your local computer, then all you need is to, say, go to the download button. Okay, this download button, if you type it, then the whole program will be downloaded to the local computer, the folder download, and then you get it, okay, immediately. And when you do the download, there's two formats that you can use. The first format is the usual Jupyter Notebook, okay, and then the next format is the complete Python program. Okay, so if you have, say, the IDLE, okay, which one for you to run Python program, then basically when you download as a Python, then the program that you develop using Jupyter Notebook can be run in the normal idle, okay, platform for Python program. Okay, so this is kind of a different way to handle it. Okay, but I can assure you that usually you don't want to download your file into your local computer. Okay, just leave it into the Google Drive. Whenever you want to work on your program, then open the Google web page and then open the file. Okay, then this is a very convenient, say, advantage that later you will find, that you don't need to, say, bring a notebook, okay, in order to carry your work along with you. As a matter of fact, whenever you go, if you can find a laptop or a computer, all you need is to open the web browser, go to Google, log in your account, and then bingo, you have all the files available, and then you can work it on that machine. Okay, it's quite convenient. So this is Google Colab. Let me summarize. This Google Colab is an application supported by the Google. And basically, you can access it. All you need is open a web page. You can go to the Google pages, and pages, the top, okay, will allow you to log in your Google account. After you log in, then next to your logo for your name, then you have a button for application. And you click the application button, and then you choose the Google Drive. so that you can bring you to the folder that contain, okay, all your documents, okay, in Google Drive. And this document can have various types, okay, Google Sheet, Google, say, whatever, okay. But one particular type of file is called Google Colab, okay. Then this Google Colab, all you need is to choose the type of Google Colab, okay. So the new file, and then choose the type is Google Colab. And you type it, then you will have a page that will show you a Jupyter Notebook, and then you can just type in your program in this Jupyter Notebook in order to create the type of event. So this is kind of the platform that we are going to use in this course. Okay, so it's very easy to use. I would strongly recommend that after the class, then you can just try. And I suppose most of you will have a Google account. Okay, just go to the account and then you can use this. Okay, Google Colab. Okay, so this is Google Colab. And as a matter of fact, this note here also introduced another, say, installation. It's called Anaconda. Now, this is just like what you have done for install the Python system into your local computer. Okay, and this is allowed you to, say, install a Jupyter Notebook into your computer. I will not go through it, and this gives you enough information. Okay, and all you need is to go to the link here, and then it will give you the instruction how to download this Anaconda, okay, platform. After you have downloaded this Anaconda platform, installed it correctly, then you will see that a lot of the new application for you to implement Jupyter Notebook. Okay, and as a matter of fact, you can just open, okay, the so-called Anaconda Navigator, then you will see this page that allows you to write various programs, okay, in support by Anaconda. Now, I don't want, now this is not essential, but I just put it there so that for those who want to install, okay, Jupyter Notebook, write Jupyter Notebook locally in your computer, then you may say try to install it. Okay, but otherwise, I would strongly recommend you to say work on your project, on do the assignment using Jupyter Notebook. Okay, after implement it, and then all you need is to download it and then back into your computer. Okay, so I just leave it for you, okay, so that you may figure out if you're really interested how to implement Anaconda in your computer for writing the notebook. So as we will focus on, okay, Google Colab as our platform to write Jupyter Notebook. Okay. Yeah. If for those, okay, if you are really interested, okay, so I will take a break of 15 minutes, okay, and during the break, you may try to open the Google page and try to say Google Drive, open a Colab file, and then you may try to type in, okay, this example create a data frame, okay, and this one is using Pandas. Why so excited? Okay. Now, but of course, you think that it's not fair. I have a friend and you don't have a friend, then we all break together. Okay, if you really want to try, then you can go to a surprise school. Okay, and try to type this program and see what you get. Okay, just for fun.
但是网上的时候是这样子，他刚刚没有说，然后
咁問下嗰個 group project 係點啊？因為個 slide 仲係大錯咗嘛。
哦，我原来怎么办？他们那个之前的话是真还有前一个特别是嘛，被留在这个所以是然后
essentially
会把那个就是他们放那个那个楼里面。
Thank you, thank you. This lecture will introduce some necessary knowledge of machine learning.
No, I'm afraid that we will just give a very basic introduction. I don't have enough data to dig. But of course, in the project and the past few semesters, the student themselves can just some problem and take it.
So are we to learn something?
Yeah, right. So this is exactly the purpose of the thing.
I see that's the background knowledge.
So basically, one will say use the limited time to cover as many different areas of the project, and at the same time, use the project to say motivate a student to self-teach all the advanced frontier techniques and work with each other. Okay, so this is two kinds of education. Right.
对，没有上去的话，用了这个分别是那3个点。如果150个都往上学，30多，差距就会太阳每个15的话，就是夜生系的，所以越把这不是第一次多天。哦，我们这个也是就是有啊，哦，也可能是
这一个月好，我一个月可能是快点快，他说在你在一对对对，我可能就是一点是第三盘是未见。我也有点，我今天上个月上
这个情况好像是花园了，跟他们不玩，我谁上还是
我一直在看的，有点难受。
就是说他原来是
我又不是。我也不知道谁怎么。
那你你是用那个不同拉菲拍可以是不是？可以的，另外因为超轻松，它会有钱，就是有开始招。可以，实际效果。我们有视觉就这个开始上好，先不说，至少因为我们的 sample data 或者 assignment 里面都差不多好，但是主要是让上面他说我是係話你哋做係嗰啲比較高係有個如果話之前如果有呢個 course 嗰啲通常都係比較長啲，即係唔係話好似即係好啲人啲可能即係你講 I P， 因為呢個 course 又唔會成日 discuss 嗰啲大概 I P 嘅事。呢個 course 係有啲係會比較長啲，講係其他嘅。 去training 嘅心機下去當。我會我又唔係我呢啲嘢，我覺得我即係未打不前。我有係啊，我之前用過你多比較唔係我哋咁樣。另外一種嘅就係第一種就第一個另外天氣咯，唔係真係分字母啊，所以知道是咁樣。我再問我所以大家看到一個 AI， 就我也有这个我觉得他是因为一些纸跟那个
Okay. So let us continue our discussion on the data science part for this course. We have already introduced the platform and the basic program type format of the notebook on using Colab to develop program. And in the next part of this slide, we will introduce a package called NumPy. This NumPy contains many useful applications and functions that allow us to manipulate array. Now, what is an array? We all know in say if you take an ordinary programming course like C++, an array basically is just a sequence of value of same type. Okay, so we have one-dimensional array of real number, okay, two-dimensional array of character, and so on and so forth. Now, why we will focus on array is because all the data that we will work on can be regarded as an array. For example, the stock price. If you say look at the stock develop a machine learning model to predicting stock price. Okay, and then the training data, the stock price, okay, that you get during various trading day, they are essentially a sequence of prices. Okay. They are all of the same type, which is real number. So this is the one-dimension array of real number for this stock price data. And for example, if you want to train a model to recognize, say, dog and cat, then the input will be a picture frame in which it divided into, say, 256 times 256, okay, different kind of value, which is real number showing the grade level of the picture. So this again is an array, but now it has two dimensions. So you have a number of rows and number of columns, but every entry in this array is of the same type, okay, which is maybe an integer, or in some application maybe even a real number. Okay, and we also have examples that you want to train and learn some, say, moving picture. then you have, okay, the input will be a 3-dimensional array. As a matter of fact, there's some application with much higher dimension. But at the end of the day, basically, most of the machine learning, say, problems are working on array. All the data can be represented by array. Okay. So, in order to say work on this kind of data, then we need to have some help to manipulate the array. Of course, we can write program ourselves using for loop, using define what kind of function, but it will make, okay, distract our, say, effort. So someone has recognized that in the data science field, there are many, okay, applications using similar function. And according to their experience, they just summarize those functions and then implement them as efficient as possible. And the result will have been collected into a, say, package called NumPy. Okay, so you will see that for those, say, data science course or machine learning course that tools are based on Python, then the first software library to cover usually is NumPy. Okay, so this is what they call NumPy. And this gives you some background information on development of this NumPy, and then you may read it yourself. Okay, but the basic point here is that this library contains many functions that provide us to manipulate or creating different types of array for us to proceed to the machine learning training part. Okay? Now, this kind of one, in addition to the function that we will introduce, and this slide also show another very important, say, operation support by NumPy is just support so-called element-wise computation. So, in order to handle, say, 2 arrays, elements by elements, usually we need to write a for loop if you work directly, okay, using Python or other programming language. But NumPy gives us a very compact and convenient way to handle this kind of operation. And this is another reason that NumPy is so popular, because it is, as a matter of fact, we'll see later that all the, say, machine learning example, most of them do not need to write, say, control looping. You don't need to see, you will not see for loop, you will not see while loop very often, because all the operations can be, say, handled by NumPy using 1 or 2 simple expressions. Do that. So this is what makes it so popular. Okay? And maybe my machine is not so okay. Okay, so now, so this is my Jupyter Notebook. Okay, now I'm going to show you some how to use NumPy. And if you know Python, then you may already know that we need to import the library before we can, say, use the function in the library. So we need to import the library. The name of the library here is NumPy. So it's number, N-U-M. okay, in Python, NumPy. Right? Okay. Now, this NumPy, just type import NumPy will be already enough. Okay, but in the community, okay, in the data science community, it kind of as a kind of a universally accepted convention here is that they in the program, instead of using NumPy, okay, then later you will see that you need to refer this name in your program in order to refer to this library. So in order to refer it, you can type NUMPY dot and then use the function. But this is a kind of a universally accepted convention is don't call NumPy, it's too complicated, and call it PNP, NumPy. So it just use an alias and a shorthand to represent NumPy in your program. Okay, so this basically is a statement to import the library into NumPy library into your Jupyter Notebook program, so that after that, then all the foreign statement can use the function in NumPy. And normally, we use NUMPY to refer this library, and then you get a dot and then the function in this library in order to access it. Okay, but you can, okay, rename it in your program. So this NumPy is the original program installed in your system, but now you can rename it in the program. So you can use instead NP to refer this library later. Okay, now, so this is important. Once you import it, then let me see. You can use it to create a NumPy array. So what is it? A, okay. A equals to NumPy.array. Okay. Now, in order to create a NumPy array, the argument can be just a list of values of the same type. Okay, it can be a list, it can be a typo. Okay, so now maybe I use list here 1, 2, 3. Okay, so you will see that when you want to create an array, okay, you cannot just type array. You have to precede it by the library name. And if you do not type as NP, then this should be NUMPY. Okay, but now you just rename it NP, then it's NP. Okay, now this NP, to be honest, is not a requirement for the syntax here. Okay, it's just a universally accepted convention that most of the data science write the program using NumPy, they just rename it in as an NP in their program. Okay, so since everyone follows this convention, it's become much more easy to communicate or use to code, okay, for other data science. Okay, so we are encouraged to use the same convention here. So it's NP. Okay, after that, then you can just print the output. Okay, and then get the result. Okay, now, an interesting point about this Jupyter Notebook is that usually you are using this Jupyter Notebook, basically after each code block, usually you want to, okay, at the end, want to look at the value of some intermediate computation. So basically, it's almost universally correct is that every code block after that, you want to see some variable content. Okay, so since this is so common, So whenever you type a code box, then at the end, if you just type the variable name without anything, okay, then interestingly, it will automatically, okay, print out the result or the content of the variable that that occurred in the last line. Okay, so this is kind of something that implemented by Jupyter Notebook that match the usual working behavior of data science. Because after every, say, code block, when they use it, then when they finish and run it, that immediately finish the execution of this code block, they want to see, okay, the content of some variable. So you see in the example that, okay, instead of typing the content of variable, you just type the variable in the last line of the statement. Then when you run this code block, automatically the content of the variable list at the last line of the statement will be displayed at the output and see the result. Okay, 1, 2, 3. Okay, and then you see that this is an array. Now, this is not a list. Okay, this is a NumPy array. And in a minute, I will show you the difference between, okay, the list of Python and the list of NumPy array. Okay, so maybe maybe I do it here. Okay, now, say for example, I have a list, an ordinary, okay. Okay, now this is an ordinary Python list. Okay, even though the format is more or less like the NumPy array. So ABC now is a list. Now, if this one, if you can add them together, if you still remember, but you add two lists together, then the result will be just the concatenation of these two lists. Okay, so if you do that, okay, you see this is the last line, so it just print the result is okay, concatenate of the two lists. Okay, now, but if you say create using this list, okay, using the NP array. Okay, then okay, then you see that essentially the content will be also 8, 1, 2, 3, and then the square bracket. Okay, but the behavior is totally different. If you add two NumPy array together, then the result is not concatenation. You just have a normal array vector add to another vector. So it's okay. They will be add elements by elements. Okay. So if this is an array, basically is the first elements of A will be add to the second elements of B. Okay. So first elements of A add to the second elements of B to get 13 and so on. Okay. So what is the point? The point is, even though the format of a list of Python and the format of a number array, when you use NumPy, even though the format will be a square bracket in which you have list of different value of the same type, okay, but they are totally different. Okay, so this is why it's very important that when you really need to have a NumPy array, then you use the np.array to create one. instead of using, okay, the usual square blanket. Because if you do that, then all you need have done is just a list, not a NumPy array. Okay. And once you create a NumPy array, then you have, say, can have some function to get more information about the array. Okay. So for example, once you get the array, then you can use the type function. Okay, this is a usual type function to determine the type of a variable. So if you call type, then you can get that this type of a here is a NumPy array. Okay, now ND array. So instead of called array, it's called ND array. Okay, and it's called as a data type. Now, data type is just the whole variable A is a NumPy array, but it consists of a list of values, and the type of those values is called D type. In this example, so you see that the value in the array 1, 2, 3 is kind of an integer, so the data type of array is integer. Okay, and since the implementation, we usually use 64-bit, okay, to represent the integer in this Colab, so its type is integer 64. Okay, and the dimension you can say in this array, since it's only a single sequence of value is one dimension, so the dimension NDIM of the array, so its property is 1. The size is the number of entry value in this array 3. Now this is very important. The shape. Okay, the shape basically is to tell you how the data are organized in this array. Okay. Now, since this is a one-dimensional array, okay, so you can see that now in your mind, the picture here, the array is not horizontal 1, 2, 3. Okay, so if you in your imagination that the array will be okay one a vertical, say 3 integer arranged in vertical with 1, 2, 3. Okay, so this one basically have 3 rows. Okay, with 1 at the top, 2nd middle, and then 3rd. Okay, so this is called okay a one-dimensional array with 3 rows. Okay, so the shape basically is tell how many rows again. So it's to be 3 because we have 1, 2, 3. So if it is a 10 numbers, 1, 2, 3, 4, 5 to 10, then the shape will be 10. Okay. Now, an important point about this shape type. This is very important because we need to manipulate it. So let us spend a little bit more time. Is for describing a shape of a data NumPy array, then the shape must be represented as a tuple. If you still remember, tuple are sequence of number handled by a say parenthesis. So this is the tuple. Okay, parenthesis and okay, so it has to be a tuple. So this is what okay. Now I will explain my somewhere here later. But this gives you another example is a NumPy array of 2 dimensions. So in order to specify it, basically we just specify the content row by row. Okay. So you specify the content of the first row, then the content of the second row, and then the content of the first row in the argument. You use NP array function to create a NumPy array. So once you create this NumPy array and then print it out, then you see the format will be like this. 2 dimensions, row by row. Okay. First row, 1.1 and 1.2. Second row, 2.1, 2.2. Third row, 3.1, 3.2. Now, the crucial point here is that the organization will be row by row. Okay? So you specify the first row, specify the second row, and specify the third row. Okay, now, again, for this 2-dimensional array, if you look at this type, it is NumPy array, is 3-type data type, that is the type of its elements, is now it's a floating point number. So 64, and its dimensional is different. It's, okay, 2 dimensions. Okay, because you have row and column, and the size is the number of entry in this array is 6. Okay. Now, here is also shape. It's very important. Okay. The shape, again, the shape of a NumPy array has to be a tuple. And if it is a 1-dimensional array, then the shape will be only one single number. If it is a 2-dimensional array, then it should be a tuple of 2 integers. The first integer will be showing the number of rows in this array, and then the second integer will be the number of columns. Okay, so you can always imagine that 3 will be the height of the array, and then 2 will be the width. Okay, so we have height is 1, 2, 3. Okay, 3 rows, and then 2 columns. This will be the shape of this array. Now, this is very important. Okay, that the shape is represented by a tuple. Now, let us go back to the 1-dimensional example. Now, I don't know whether in your, say, study of NumPy, when you are in the graduate, whether you have come across this already. So, again, we all want to have specified a tuple by enclose it by a parenthesis. This is the syntax. Okay, but so this does not consist of any problem if you have more than one element in this tuple. Okay, because you have a comma, that is all good. But if just imagine that the tuple has only one single number, say 3, then if you just type 3 and then enclose it by a parenthesis, okay, then Python will not regard it as a tuple, but just regard it as a single integer 3. Just imagine that. Okay, you print a number, maybe I do it in this way. Okay, so for example, we want to create tuple 1, say for example. Okay. Now, the type here, maybe. Okay, the type that if you intend to create a tuple with one single integer, and then so if you are just using a single integer and close it by a parenthesis, just like this, okay, what you get is not a tuple, but instead an integer. Okay, why? Just imagine that you want to print, say, 1 plus 2. Okay, so this is a valid expression. Okay, so it's 1 parenthesis plus 2. So we can always, in an arithmetic expression, we can always enclose the number by a parenthesis. Okay, so this basically is, okay, what they will expect if you have a single integer, enclose it by a parenthesis. They will just treat it as an ordinary arithmetic expression. Okay, and that the result will be an integer. In this case, it's not a typo. Okay, so in order to solve it, usually, okay, then we will just, instead of just like this, you just artificially put a comma here. Okay, and then you get a typo. Okay, I have spent quite a few minutes on this, but this is very important. Okay. Okay, so for one-dimensional array, which we will encounter quite often, so we have to make sure that what is its shape? Its shape is not just its length enclosed by a parenthesis. If you do that, then the result is not a shape, but it's an integer. So make sure that it is the length of the number array, and then followed by a comma in this case. Now, this is first. And second, when you look at a number array, basically, we always start with that. Okay, the first number is for the number of row, vertical. Okay, the second number is the number of column, a three-dimensional array. Okay, so in this case, okay, so even though you type it as 1, 2, 3 in horizontal, but in your mind, okay, make sure that the picture will be 1, 2, 3 vertical. Okay, for a 1D array. Okay, and then for the 2D array, it will not be a problem for 2D array, so it's 3 row and 2 column. So this is to make sure that the convention is consistent. Okay, the first number will be the number of rows. The second number will be the number of columns. Okay. Now, fortunately, okay, we do not need to handle three-dimensional array. As a matter of fact, if you really need to take a course focus on just machine learning, then you need to usually handle three-dimensional array, even four-dimensional array. And then for those arrays, you need to reshape it, okay, in even 5 dimensions in order to fit in the input requirement. So basically, it will be quite messy. Okay, but for this introductory course, we will only working on 1 dimension and 2 dimensional array. As a matter of fact, even though for we only work on 1 dimension and 2 dimension, we need to reshape the dimension. Okay, here give you some examples. And well, maybe not this page. Okay, next page we will use the shape. But this one, okay, it gives you. So in order to work on an array, so you first need to create an empty array in order to say update it later. So here is I showed you different way to initiate an array. So because 0 and 1 are so common. So here I know how to create a function called 0 and a function called 1. Okay. So now So in order to call it, so it's called NumPy library, NP dot, okay, the function 0, and then it has an argument which is the shape, okay, which is the type of, okay. And of course, the number of integer in the shape corresponding to the dimension. And in this example, the shape is a 2-dimension array, specify 2 rows and 3 columns. So basically, the resulting array will be a 2-dimensional array with 2 rows and 3 columns. 2 rows and 3 columns. And 0, you guess, basically, each entry in this number array will be initialized to 0. If in this example, NumPy 1's 4, 2, so it's again is 2-dimensional array, and it has 4 rows, 2 columns, and its value is 1. Now, all these functions, the type will not be integer, but is a floating point number. It's a real number. Okay, so please be aware of that. Okay. Now, and in addition to this, you can also create a 1-dimensional array. Okay, that will say give you a kind of a arithmetic progression that is uniformly spell out the content of the range. So it is very similar to the range function provided by the standard Python. Okay, but since this is a NumPy, so you have a range. Okay. So a range, later you immediately will see that it's a little bit different from the range, okay, function in Python. Okay. But anyway, the usual syntax are, okay, starting point, ending point, and then the increment. Okay, in the range, okay, a range function. Okay. Then the result will be this a range will construct a sequence of, now here is integer, starting from 0, the starting point here, and then it will successfully increment and set up incremental, it is get for 2, 2 plus 2, get 2, 2 plus 2, 4, 2 plus 4, 6, and 2 plus 6, 8. Okay, and again, according to following the usual convention of Python, okay, then it will not include the last n. The period. Okay, so if you type n, that means that even though the increment eventually reach 10, but it will not include. So basically, this will be excluded, while the starting point will be included in the resulting series. Okay. Now, a point of note here is that usually students, when even for me, when I type in very time, instead of a range, we type a range, ARANG, okay, instead of ARANG, and then run it and get the error and you don't know what. Okay, so basically, this is not a range. This is a range. Okay, now this a range is a little bit different from the range. Okay, support by Python is because for the one support by Python, all the argument has to be in. Okay, for a range, then it can allow you to have, say, an argument that is real number. Okay, so this is another difference. Okay, now another way again is to say create a sequence of number. Okay, but instead of fix the increment, basically you do not need to calculate the increment yourself. You just tell it the starting point, ending point, and then you just ask the function called lin space to divide, okay, this number from 0 to 10, okay, into 5 equal point with equal distance. Okay, so basically you just in an interval, and then you just put 5 point unit point. So this is what we get here. Okay, now this is very useful. because if you want to plot, okay, a graph from X and Y, okay, basically the X, okay, usually you want to have an equally distant point in fixed interval, okay, to put the X, okay, there, okay. So this can be easily done by using these lines in function. Okay, and here it just gives you the another way to create a number array with dimension. Okay, in a random number. Okay, so this is a number array. Now,
So can you explain why we need to random?
how to say, in some applications. So basically, for example, you want to simulate operation. Okay, that will make random choice. Okay, now here show you an example that why I emphasize so much on the shape, but this is not okay the real reason. Later you will give more examples that why we need to do shape. Okay, because usually the input data that you have and the input requirement of the machine learning model construction algorithm basically is not the same. So you need to manipulate or massage the input data in order to make it agree with the requirement of the input and of the machine learning. So you need to do it. But here is another example to show you the shape. Okay, now here. So for example, I use the A ring to create a sequence of numbers starting from 0, ending with 12, but not include 12. If I do not give the third number, by default it is 1. So this will give me a number array from 0 and 2 to that. So totally we have 12 of that. This is one-dimensional array. Now, NumPy have a function called reshape. To call it, not using np dot no. Okay, it is a method associated with the NumPy array. So for NumPy array A, then you can type dot reshape to reshape this NumPy array into another NumPy array with different shape. And then the content later you will see how to construct it. So basically, now this function applied to A will not make change of content of A. It will create a new NumPy array. So when you call A reshape, it will not have any effect on original content of A. But instead, this reshape will create a new array whose arrangement will agree with the shape that you type in your program, right? In the function call. Okay? So here it just asks, okay, the system of the NumPy to reshape this list into another shape, which is 4, 2. Okay? 2 points that I want you to bring your attention. Okay. The first point here is you see that 4, 3. Okay. As I've always mentioned that for shape or reshape, the argument has to be a tuple corresponding to shape. Okay. But now it does not show that it is tuple. Okay. So to be honest, indeed, you need to put a parenthesis around 4 and 3. Okay, in order to specify that it is a tuple, specify the shape. This is the content, it is the syntax statement. But still remember, in Python, okay, to specify a typo, the parenthesis is optional. You still remember? Okay, so if you want to specify a typo, say A and B, okay, so your parenthesis A, comma B. But this parenthesis from Python allows you to omit just type A, comma B. Okay, so I just want to make you to pay attention that if even though it shows that it looks like it has two arguments, but indeed it is one single argument whose type is typo. Okay, so but it happens that I did not put the parentheses to group these two numbers into a single entity, so it looked as if it contained two arguments. No, just one single argument, and the argument will be corresponding to shape. Okay, and the job that we asked to do is to given this 12 number arranged in a one-dimensional array, okay, and we arrange or we position these numbers into a two-dimensional array of 4 rows and 3 columns. So just imagine that you have an empty 4-row and 3-column array, and then you just copy the content of this one-dimensional array A into this template, the empty array. So this is 4 columns, 4 rows and 3 columns, and empty, and then you copy. How to do the copy? Left, right, top, bottom. Okay, so just imagine that this is empty, and then the array that you create by this reshape function will be 0, 1, 2, 3, 4, 5, so scanning in this way, but left to right, top to bottom is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is that. Okay, now so immediately there's a requirement. So this is the second one I want to do. And is the number of the original array should be equal to the product of the row and number of row and column in the reshaped array. So since we have 12 numbers here, so basically the container, the new number array, its number of row and number of columns should contain a 2D to create a 2D array with the same number of entries. So if the number of values to be copied is 12, then the number of entries in this new array should be 12. As a matter of fact, 4 rows and 3 columns is equal to 12. So okay. But you cannot say reshape it, this array into 3, 3. If you do that, you get an error message, because the number of entry in the original array and the number of entry in the resulting reshaped array should have the same size, the same number of entries. Okay? And here is another example here. Now you have a 2-dimensional array with 4 rows and 3 columns, and then you want to reshape this 2-dimensional array into same 2-dimensional array, but with different rows and different columns. Okay, so and I mentioned that the copying will be left to right, top to bottom, in the and sum. Then the way to pick out the entry in the original array is also left to right, top to bottom. So basically, the process will be get the value 0, 1, 2, 0, 1, 2, and then 3, 4, 5, 3, 4, 5, 6, 7, 8. Okay, now we move it to here, 6, 7, 8, and then 9, 10, 11. Okay, so this is all the shapes. Okay, I don't want to say spend too much time on it, so you run through the example to get the idea. Okay, but I will recommend you to at least be familiar with this kind of to shape an operation because our example kind of later is used. Okay. Oh, I've already showed you here. Okay, a NumPy array is different quite substantially with a NumPy Python list. Now, here is to show you, okay, the kind of one of the major advantage of using NumPy array is it makes your operation much more sustained and simple. Okay, so here is an example here. You add two NumPy array together, elements by element. Then you can imagine that if you use Python, then you need to write a for loop to go through the array entry, one by one, and add them and add it to the array, a new result. Okay, so you need to write a for loop to do that. But if you apply the same capability of NumPy array, then instead of writing a single for loop, then you can just specify the operation that we want to apply with the elements of this two array. And that gives the two array the outcome. Then it will automatically add these two array elements by element. This is one example. Not only that, you can also do not adding another array, but add a constant scale. But imagine that a plus 4, and you just type it, then you can imagine that every entry of a will be incremented by 4, 1 by 1. You don't need to write for loop to do that. Okay, and also multiplication or division. Okay, so hopefully it will at least immediately give you one reason why NumPy array are kind of preferred choice in making program. It will make the program much more easy to read instead of going through the logic of loop. You immediately know that this is what you want. You want to add all the elements by each. For example, not only that, you can apply the function support by NumPy to an array. Basically, this NumPy square root is applied to an integer or floating point number. So you can have np square root and the entry is 4, then you will get 2 with square root. Instead of one single argument here, if you put the argument which is whole and a single array, then you will get not a single value, but the square root will be applied to every element in the array, and that is one single call. You get a new vector or new array. All the elements are just the square root of the original one. So it's so powerful. Not only the square root, there's a lot of other functions that you can use. And this is just the example here. So maybe you just try it yourself. So this is nothing very deep. Just to show you the simple and convenient way to tell the program how to manipulate the data. So as a matter of fact, later you will see many examples in our course, such that you don't need to use write or loop or while loop thing. Just very simply apply the package API, put in the argument, by using this kind of capability, then you can manage the shape the argument very easily and sustain. So as a matter of fact, the data science, the practitioner of data science usually is not very good program. Okay, because they don't they don't need to write complicated program, because it can be handled very sustained and very straightforward. And this is expected. One the designer of various package of that we see here is the one to free the data analytic on the programming part on the job, so that they can focus on the data. Okay, so using Python still may not give you the insight or the real feeling on the difference between a CS programmer and a data. But if you take a data analytic or data science course that use, say, the language R, then you have a very strong feeling that data analysis is not focused on revenue. They focus on data, different set of data. Try write some command in order to reshape it, in order to restructure it and get some important information to kind of filter it into something more data that's more relevant to your analysis and so on and so forth. So basically, the programming part is not the main part. Okay? And this is example of creating or reshaping a 3D array. Okay, so from 1D array into 2D array, and then apply this organized operation to increase every entry by 1. Okay, so you try yourself. Again, here I just want to remind you that this, okay, is not two numbers here, but it's just a single argument, which is an apple of two numbers. Okay, so this is one example, and also this example shows you that you can multiply to two-dimensional rate, okay, which is matrix. So multiply, but this is not, okay, the matrix multiplication, but it's straightforward elements by elements multiplication. Okay, so for example, this array, 1 times 3 is 2, so you get 2 here, 2 times 2, you get 4 here, and so on and so forth. Okay, so all these operations are elements ones. So in order to specify it, basically you only can specify it on terms of whole array. Then automatically the system will apply those operations to this entry, okay, one by one review. Okay. Another example. Now, we know to reshape it. And again, you can imagine that the kind of data analytic, we want kind of, say, from a large array to assess part of them in order to focus on some part to do the data analytic. So basically, we need, okay, often need to assess part of the array. And we have already this kind of mechanism in Python. Okay, so if you still remember, we have the index operator to access or get the individual row or individual column or even individual elements in the array, in kind of this. And also, we have the slice operation, slicing operation that will say get, okay, a sequence of rows, okay, according to some criteria in order to get the type of it. Okay, so this slide is focused on the job that we need to assess individual part of the array. Okay, pick them out for further analysis. Okay, and here is give you an example. So you are going to create a three-dimensional array with 3 rows and 6 columns here. Okay, and now basically this is what we have. Okay, that we use the indexing operator. Okay, and then you have a 0. So remember, just like Python, that an array, the row and columns are associated with an integer, such that the first row with index 0, second row index 1, so on. And for the column at the same, the first column index 0, second column index 1, and all the way to the last. And in order to access, say, an individual elements in this array, all we need is to use the indexing operator to specify the row index and the column index. Okay, so let me see. For example, this array A, I want to access this element. This element is in this row. Now this is the first row, so index 0, and this column, first column index is also 0. So this 0 index for it is the row index 0, column index 0. So this is the way we make in order to refer to it. A is the name of the three-dimensional array. Okay, and then we access the index, the row with index 0 corresponding to, and after that, we want to access the column with index 0. Row, column 0, here, 1, 1, index 1, row index 1, column index 1, index so on. Okay, so this is using the ordinary indexing operator with the index. Okay, the next example is to apply the slicing operation. Okay, so still remember the slicing operator is a colon starting with the starting point and ending with starting index and ending index. Okay, now let us see what it gives us. So first, this array A, focus on row 1, and then the column will be index 1 all the way up to index 4, not 5. The last thing, the right hand will not be included in the result. Okay, so 5 will not be included. The index before it will be 4. So it's 1, 2, 3, 4. So first row, index 1, and then from 1 to 4 to 0, and then this is the starting point. 1, 2, 3, 4, 7, 8, 9, 10. So when you do that, you get 7, 8, 9, 10. Okay? Now, this one, I'm sorry, I'm a little bit confused. Okay, I should not type this one. Basically, it should be using this one. Indexing operator 0, 2, and then another indexing operator 0, 4. So we just specify the number of rows. Okay, but it happens that Python a little bit more flexible, that in addition to this way to specify it, then you can specify it coming. Okay, that's one of other way to assess individual part of the Python. Okay, but anyway, this is the basic way. Okay. Now, that's one particular confusion that you may encounter by applying the slicing operator. Okay. Because from time to time, instead of working the positive index to specify the slicing, sometimes you will, at least in some sample that you get in the textbook or other written by other programmers, you will see that they often like to use negative index in order to specify the slice. Because, to be honest, sometimes specify a negative index will be much more convenient, okay, and straightforward. Okay, so I want to, before we leave tonight, I want to specify how to, another way to specify elements in an array, okay, using the index. So normally, so this is the array. So normally the index is from left to right, in this case, such that the first one with index 0, second one index 1, all the way up to, okay, the last one in this case is index 8, which is the total number of elements minus 1. Okay, so the total number of elements is 9, so the last one is 8. Okay, so this is normal positive index to specify the elements in the array. Okay, but there's another way that you can use is the negative index. Basically, is starting from the right-hand side, and then it's -1, -2, all the way up to -8. Okay, so this is the two different ways to allow you to specify an element. For example, for these elements, okay, this can be up in this form. For this element, basically, you can access it by A3, okay, because this corresponding to this position, or you can using A -6 to specify the same entry here. Okay, so basically, this is what I want you to know. There are two different ways, okay, to use index to access an entry in a number array. Positive index, negative index. Now, the fundamental question basically you need to know is, given a positive index, then you should immediately know, okay, the corresponding negative index. Okay. So you can look at this picture, okay, and then you just find out the corresponding, but it's too complex. Okay, so I can tell you a shortcut here. Okay, so for example, here. Now I know that the length of this array is 9. Okay, now suppose you know that I want to convert A3, okay, the index 3 to the corresponding negative index. Okay, so suppose you have 3, you do not know 6. Okay, so basically what you want is you want to create from 3, from it, you create a negative number, okay, corresponding to the negative index. So you ask yourself, given the positive number 3, how to get a negative number? Minus something. Okay, so you immediately know that the formula will be, okay, the input integer, okay, positive integer index, and then you must minus something. Okay, but in this kind of array, what do you know? That's something that is meaning nothing. It's just the length of this array. Okay, so this is only possible, okay, choice that you have. Okay, so basically the formula is very easy. Given a positive integer, in order to get the negative integer, you minus something. What is that something? Well, nothing except the length of the array, which is the length of the array, which is 9. So 7 minus 9 is 2. For here, 4, in order to get the negative index, you minus something, you know nothing except the length, which is 9. So 4 minus 9 is 5. Okay, so this is very easy, just immediately. And vice versa, you do exactly the same thing. Given a negative index, what is the positive index? You need to add something to it. Some negative number, you add something to it to get a positive number. Okay, so what is that something? You know nothing. The length of the rate. So this is an obvious choice. Okay, so negative. Okay, then you add 9, you go back to the positive. -4, you get 9, you get plus. Okay, so this is kind of some kind of trick that you can remind yourself that whatever situation given a negative index, it is kind of straightforward to convert it into positive index. Why we want to do that? Here, okay, when you read example written by different programs, sometimes usually in data science they need to use the slicing operation to get the important component of the data set, get it out, and then focus on them to do analysis on that. Okay, so they usually use slicing operation. Okay. Now, for the slicing operation, sometimes it will be much easier for us to see what they want to get by just convert all the negative index into positive index. Okay, and then it will make them into things. But this is one thing. Another thing is it will also help, okay, to understand, okay, to get out the final result if you try to convert every index into the positive index. So what I'm saying is, so now this is kind of the rule. I will leave it to you to read it. Okay, but for here, I want you to do an exercise. Okay, after you read through. Basically, this is given an array. Okay, and then you use the slicing operator. Okay, to specify the individual components. And this slicing operator usually composed of the start, okay, index, the ending index, and then together with an increment step. Okay. The point is sometimes you don't need to specify every component. You can leave it, okay, blank, so that you can use the default, okay, value to be the starting index. And the rule is here. Okay? And in order to apply this rule, basically it will be much easier that given any question that you need, okay, and according to the rules, it is better to convert the negative index to positive index. Once you do the conversion, then you can immediately figure out what entry that you need. Okay? Now, I want you to spend some time to go through the rules, okay, for the slicing operation, okay, and then try to apply this rule to figure out what this slicing operation will give you. Okay, and my suggestion is that if you find it kind of confusing on how to handle everything, then just try. If you do not know how to do that, just try to convert them into, okay, a positive index first in order to get the result. Okay, so so they are urging us to leave. Okay, you see the sign here. So maybe we should stop. Don't worry. So basically, we will stop here and price what our achievement.
我